This is the Algebra 2 Pre-AP Unit 3A retake practice. So looking at the first one, it says complete the square and give the vertex of the equation. So when we complete the square, we rewrite this. We have y equals, we open a parenthesis, x squared minus 4x plus, we leave some space, close the parenthesis, plus 9 and minus, we'll leave some space. To figure out what goes into this first blank space, we take half of our middle term value, so -4, half of -4, which is -2, and then you square it. -2 squared is going to be +4, so the 4 goes there. And because I am adding 4, I also have to subtract 4. So the 4 goes out here. The goal in completing the square is to create this perfect square trinomial that I can rewrite as a binomial square. So that is going to factor as, so you're looking for two numbers that multiply to give me 4, add to give me -4. That's going to be -2 and -2, which is what we want when we're making these perfect square trinomials. So it becomes x minus 2 squared, and then I still have on the outside 9 minus 4, so plus 5. And that is going to be my equation in vertex form. So it already has the y equals x minus 2 squared plus 5. My vertex is at the hk value. So the vertex form equation is y equals a x minus h squared plus k. So since this is -2, my h value is 2, plus 5, my k value is 5. Okay, looking at the second one, do the same process. Y equals, I open my parenthesis, x squared plus 6x plus a blank, and then close that parenthesis. Then I have the minus 10 and minus a blank. So I take half of this, so 6 divided by 2, and then square that. So 6 divided by 2 is 3. 3 squared is 9. So here I add 9, and out here I'm going to subtract 9. This is that perfect square trinomial. So to get it factored, I do x and then half of that b value, so plus 3. And I square it, and then I still have on the outside -10 minus 9, so minus 19. Now this time, because the vertex form equation is x minus h squared, and here I have x plus 3, that means that my h value is -3, and my k value, being minus 19, is minus or -19. The third one, so got y equals, open my parenthesis, x squared plus 12x plus, when you're writing the perfect square trinomial, inside you always have a plus, and on the outside, when you're completing the square, you always have the minus. So I take half of this, half of 12 is 6, 6 squared is 36. So I'm going to add 36, which means I need to subtract 36. So my perfect square trinomial is right here. I rewrite it as the binomial squared. So that is x plus 6 squared. And then I have 36 minus 36, which leaves me with nothing. So I don't have to write anything further here. Now, because this is plus 6 in there, that makes the vertex point -6. And since there is nothing written out here, the k value is 0. The vertex is at -6, 0. In 4, 5, and 6, we now have an a value in front. So what we have to do, we have to factor that a value out of the first and the second terms. So we factor it out, we have y equals, we take that 2, that's the a here, and put it in front, and then we open the parentheses. And now we have x squared. And I say, okay, since I took the 2 out, I have the negative 12x divided by 2 is going to be negative 6x. I have the plus, and I leave some space, and then I have the plus 9, and then minus, leave some space. When I am figuring out what goes into this blank, I am looking at my new b value, not my original one, my new b value. So I take half of -6, which is -3, and I square that. That gives me 9 that I add. What goes on the outside, because I have this 2 in front, what I really added was 18, because I have 2 times 9, so that's what I have to subtract, is my a value times my new value that I added in. This is still my perfect square trinomial, and that's what I want to write as the binomial square. So it is x and then half of my b value minus 3 squared. But I can't forget the things that were in front and behind it. So in front, I still have that 2, and behind, I have 9 minus 18, so -9. My vertex, the a value has no bearing on my vertex. All that has, my vertex is still just h and k. So my vertex is at the point 3, -9. And at number 5, I have to factor out the 3 out now. So it's y equals 3, open that parenthesis, so that I have the x squared, and then I say 24 divided by 3 gives me plus 8x, and then plus, I'm going to leave some blank, and then I have plus 16 minus a blank. So I take half of 8, which is 4, and I square that. 4 squared is 16. And then to figure out what goes on the outside, what I subtract, it is 3 times 16. That's going to be minus 48. This is my perfect square trinomial that I rewrite as my binomial squared. So it is x half plus 4 squared. I keep the 3 in front. And then behind I have 16 minus 48, so negative 32. My vertex comes from those numbers, so it is negative 4, negative 32. Looking at 6, the 4 is what my a value is, so that's what I need to factor out of the first and the second terms. So I have x squared plus 8 divided by 4 gives me 2x plus some space, and I have the plus 3 and minus blank. What goes in here? Half of 2 is 1. 1 squared is just 1. So I have plus 1 that I added. What I subtract is the 4 times 1, so minus 4. My perfect square trinomial. Rewrite as my binomial square, so x plus 1 squared. I take the things that were in front and behind and keep them where they were. So I have 4, and then behind minus 1. So the equation is y equals 4x plus 1 squared minus 1. So my vertex is at the point negative 1, negative 1. 7, 8, and 9, we are determining the characteristics of the graphs. For all quadratic functions, my domain is negative infinity to positive infinity. To figure out my range, there are 2 things that I need to take into account. One is, does it open up or down? Because there is the negative out in front, that tells me that it reflects, and this opens down. So the lowest my range goes down to is negative infinity. The highest my range will go up to is my k value, 9. And it will reach 9, so I will close that side off with a bracket. When the equation is in vertex form, it's very easy to find the vertex. It is the hk. So my vertex is the point 3, 9. My axis of symmetry is x equals h, and so my h value is 3, so my axis of symmetry is x equals 3. Because this opened down, my vertex is a high point or a max point, and it's the maximum point of 9, because that's how high it goes up to, at x equals 3. When I am increasing, I am caring about the x values only. I want to say, as I move from left to right, what x values make my y value move up. So that is, as this comes this way, I'm going up. So from all the way to the left, negative infinity, until I get to the x value of my vertex. So until I get to 3. That is when I am increasing. I am decreasing from the x value of my vertex, 3, until I get to positive infinity. Positive infinity, even though it is going down, positive infinity because I'm moving to the right. So looking at number 8. Again, the domain is always negative infinity to positive infinity. To figure out my range here, I need to see, does this open up or down? Because there is no negative here, this opens up. So the lowest point that I go to now is going to be my k value, which is this -1. And it will touch it, so I close that side with a bracket. The highest it goes up to now is to positive infinity. My vertex comes from my h and k. So my vertex is -5, -1. The axis of symmetry is the x value of my vertex. X equals -5. Because this opens up, I have a minimum value of the lowest point I go down to, -1, and that happens at x equals -5. Here I am increasing, there's my vertex, I'm increasing from the x of my vertex, so I'm increasing from -5 as I move right to infinity, and I am decreasing as I come from the left from -infinity until I get to the x of my vertex, -5. My domain is still and always -infinity to infinity. My range, this negative tells me that it opens down. So the lowest it goes down to is -infinity. The highest it goes up to is my k value. Because I do not have anything on the outside here, that k value is 0. And you close that k value side with a bracket. My vertex is hk. The h value is -1. The k value is 0. My axis of symmetry, x equals h, or the x value of my vertex, so -1. Because it opens down, my vertex is a maximum point, and the highest that it goes up to is 0, and that happens at x equals -1. As I move from left to right, I'm increasing from -infinity until I get to the x value of my vertex, -1. And then I am decreasing from the x value of my vertex, -1, until I get to positive infinity, because it's as I move further right. Questions 10, 11, and 12 are talking about an axis of symmetry and 2 points. So what you want to do here, and it's just wanting to know what other 2 points have to be on the parabola. An axis of symmetry is a vertical line over which your points reflect. So it says my axis of symmetry is x equals -2. So just draw a little sketch. If I've got x is -2, and I have these 2 points of -1, 2, and -4, -3. So if I have -1, 2, well, that is going to be further right, because that is more positive. Okay, so I can label that point as -1, 2. And then this one of -4 3. To figure out how this reflects, take the point from -4. How far do I have to go to get to -2? Well, I have to move 2 spaces. So to make it reflect, I move an additional 2 spaces, and that gives me my new point. My y value has not changed. I did not move up or down at all. So that is still -3. But what did happen is my x value moved from its original location at -4. It moved 4 to the right, putting it at 0, -3. So that is one of my additional points, is 0, -3. Figure out the other one. I'm here at -1, 2, and I have to move 1 to the left to get to my axis of symmetry. So I move an additional 1. That gives me my new point. So from -1, moving down twice, -1 minus 2 gives me -3, and my y value did not change, so it is still 2. So the other point that I have is -3, 2. Those are the 2 additional points that I have on that. Here, I've got an axis of symmetry at x equals 3. So I draw a little sketch, x equals 3, and I put the points that it gives me. I have 5, 1, and 2, -2. So 5 is going to be up here, 5, 1, and then 2, -2. Okay, so to go from 2 to 3, I have to move 1. So I move that 1, and then to reflect to the other side, I have to move an additional 1. So 2 plus 2, if you hit the point 4, my y value did not change, so that stays at -2. So one of my additional points is 4, -2. From 5 to get to my axis of symmetry of x equals 3, I have to move left twice. So to reflect, I move an additional 2. So from 5, I've moved a total of 4 over. So 5 minus 4 is 1. My y value did not change. It is still 1. So my other point here is the point 1, 1. My axis of symmetry this time is x equals 1. I put the points that I'm given of 0, 4. So 0 is going to be right there. Label that as 0, 4. I also am told I have the point -1, 0. So that's even further to the left there at -1, 0. From 0 to get to 1, I make 1 jump. So I go an additional 1 there, putting that point at 2, 4. From -1, I make 2 jumps. So I go an additional 2, putting that point at 3, 0. So the other 2 points I have are 2, 4, and 3, 0. transformations, if you have a negative out in front, that tells you that it reflects over the x-axis. A value that is inside parentheses of what is being squared, this is a b value, which is going to be a horizontal stretch or shrink. This, that is a fraction, ends up being a horizontal stretch, and it is a stretch by the reciprocal. So it is a horizontal stretch by 3 halves. The -5 here, that is my h value, and that shifts it right 5. The +4 is my k value, and that shifts it up 4. Looking at number 14, this too is not part of what is being squared. It is outside of the square, so that is going to be a vertical stretch or shrink. Because it is greater than 1 vertically, that is going to be a vertical stretch by 2. It is only the horizontal stretches or shrinks that are opposite of what you believe. The vertical stretches stay true to what you think. Because it's greater than 1, it's a stretch by that number. The horizontal one, less than 1, becomes a horizontal stretch by the reciprocal of whatever value you have. The +3 shifts it left 3. The -6 shifts it down 6. Looking at 15. This 4, once again, is inside what is being squared. So that makes it a b value. So it is a horizontal stretch or shrink. And because this number is greater than 1, that makes it a horizontal shrink by the reciprocal of 4. 4 can be written as 4/1. So the reciprocal of it, you flip those and you have 1/4. The +8 is a horizontal shift, and that shifts it left 8. The -12 is a vertical shift, shifting it down 12. 16, 17, and 18 are when it gives it to us in vertex form and wants us to put it into standard form. The way we do that is through following our order of operations. So the first thing that I have that I can do, I have this exponent. So I need to do x minus 4 multiplied by itself, x minus 4. So you FOIL or do double distribution, same thing. Some of you like doing the box method. Whatever your method is fine. You've got x minus 4 times x minus 4. So you take x squared. On the outside, x minus 4 is going to be negative 4x. Inside, negative 4x is another negative 4x. And then the outside, negative 4 gives me positive 16. So So I combine my like terms there. I have x squared minus 8x plus 16. I keep this in parentheses because that is just taking care of that squared part. I still have the 2 that is out in front of it and the minus 9 behind it. Next thing order of operations says is to multiply. So I'm going to distribute this 2 to all parts. So I have 2x squared, 2 times negative 8, minus 16x, 2 times 16 plus 32, and then I still have that minus 9. So now I just combine further like terms with this 32 and 9, and I get y equals 2x squared minus 16x, and then 32 minus 9 plus 23. Okay, again, follow those same steps. First thing I need to do, I need to FOIL with that squared. So I have x plus 2 times x plus 2. That gives me x squared plus 2x plus 2x plus 4. Combine my like terms. X squared plus 4x plus 4. I bring that negative 3 that's in front. That has to stay in front. And then the plus 1 that is behind needs to stay back there. Next is to distribute this negative 3. So I have negative 3x squared, negative 3 times positive 4x minus 12x, negative 3 times 4 minus 12, and then I still have that plus 1. Further combine like terms and you get y equals negative 3x squared minus 12x, negative 12 plus 1 minus 11. At 18, I square this, x minus 1 times x minus 1. That gives me x squared minus x plus 1. Combine the terms, I have x squared minus 2x plus 1. This 2 that's in front needs to stay in front of it, and the plus 5 needs to come behind it. Next, I need to distribute that 2 to all parts in the parentheses, so it is 2x squared minus 4x plus 2, and I bring that plus 5 with it. So y equals 2x squared minus 4x plus 7. (19 through 21) are saying to write the equation for the graph. Okay. We have a vertex and a point. We want to write these equations in vertex form. So we want to write it y equals a x minus h squared plus k. A vertex gives us an h and a k value. A point gives us an x and a y value. So if we have h, k, x, and y, and we're putting it into vertex form, the only value we are missing is a. And so that is what we are looking for. So I plug these values in the equation where they go. So I have -9 equals, I don't know my a value, so I leave that as an a. I open the parenthesis and I have x. My x value is -1. Minus, my h value is -2, so it is minus -2 squared, and then my k value -6. When you subtract a negative, you are really adding the positive value. So it is -1 plus 2. So I'm going to do is I'm going to add 6 to both sides. So now I have -3 equals a, and here I'm also going to combine this. -1 plus 2 is going to be 1 squared. 1 squared is just 1. So I have -3 equals 1a. Since I only have 1a, I don't need to divide by anything. A equals -3. Now I can rewrite in this vertex form, plugging in the a value that I just found. So I have y equals -3, open the parentheses, x plus 2 squared minus 6. When you are rewriting, or when you are writing your equation, you want to keep the x and y as variables because you want to know all points on the line, or all points for the function. You don't want to put the x value of -1 in because that will give you a y only at a particular point. Looking at 20 again, my vertex gives me an h and a k value. My point gives me an x and a y value. So I have 10 equals a, because I don't know my a value. Open the parenthesis, x, or -6, minus the h value is -3, which again, if I subtract a negative, becomes plus 3 squared, and then plus my k value, 4. So I'm going to subtract 4 from both sides. I have 6 equals a, and in here, -6 plus 3 is -3 squared. -3 squared is 9, so I have 6 equals 9a. To get the a alone, I need to divide both sides by 9. So a equals 6/9, which reduces to 2/3. So my equation is y equals 2/3, parentheses, x plus 3 squared plus 4. And our last one, again, an h and a k value come from my vertex, and my point gives me an x and a y value. So I have 7 equals a x, which is 3, minus h, 5, squared, plus k, minus 1. I'm going to add 1 to both sides. 8 equals a. 3 minus 5 is negative 2 squared. Negative 2 squared, negative 2 times negative 2 is going to be positive 4. So now I needed to get a alone. I need to divide both sides by 4. I get a equals 2. So my equation is going to be y equals 2 x minus 5 squared minus 1.